Picture this, a doomsday clock, not ticking towards some human-made catastrophe like war, but toward a natural disaster so colossal it could reshape life as we know it. We're talking about a supervolcano eruption, a geological juggernaut that could plunge the planet into chaos. For centuries, we've stood in awe of these sleeping giants, feeling utterly powerless. But what if that's changing? What if humanity, with all its ingenuity, could actually take on one of Earth's deadliest phenomena and win? Buckle up, because we're diving into the audacious, mind-blowing ideas scientists are exploring to stop a supervolcano eruption and whether they're even remotely possible. Let's start with the stakes. A supervolcano isn't just a bigger version of your average volcano, it's a beast. Take Yellowstone, for example, probably the most famous supervolcano on Earth. If it erupted, it wouldn't just ruin your weekend plans in Wyoming. We're talking about an event that could blanket half the United States in ash, trigger global climate shifts, and cause what scientists grimly call a volcanic winter. Imagine skies darkened for years, crops failing worldwide, and temperatures plummeting. Studies estimate a Yellowstone supereruption could release 1,000 cubic kilometers of material enough to bury entire states under meters of ash. For context, the 1980 Mount St. Helens eruption, which was devastating, spewed out just 1 cubic kilometer. Yellowstone's last major eruption, 640,000 years ago, left a crater so massive you could fit a small country inside it. Supervolcanoes are rare. Thankfully, there are only about a dozen identified globally, including Yellowstone, Toba in Indonesia, and Toba in New Zealand. What makes them super is their ability to produce eruptions with a volcanic explosivity index (VEI) of 8 or higher, meaning they can eject at least 1,000 cubic kilometers of material. Regular volcanoes, even big ones like Vesuvius, rarely exceed VE5. The scale is logarithmic, so a VE8 eruption is 1,000 times more destructive than a VE5. The Toba eruption 74,000 years ago, thought to have nearly wiped out humanity, reducing our population to a few thousand survivors. That's the kind of existential threat we're dealing with. Right now, scientists are watching these giants like hawks. At Yellowstone, the U.S. Geological Survey (USGS) runs the Yellowstone Volcano Observatory, monitoring everything from ground deformation to earthquake swarms. Tiny changes like the ground swelling a few centimeters or a spike in seismic activity can keep experts up at night. Yellowstone's caldera is active, with hydrothermal features like geysers and hot springs hinting at the molten chaos below. Before we get to the wild plans, let's talk about why this is such a tall order. A supervolcano isn't just a mountain with a bad temper. It's a vast, complex system driven by a massive magma chamber, sometimes dozens of kilometers wide, sitting beneath the Earth's crust. This chamber is like a pressure cooker filled with molten rock, gases, and heat. When the pressure builds to high, the crust above can't hold it back, and boom, you get an eruption that makes Hollywood disaster movies look tame. The sheer scale of the system makes intervention tricky. You can't just plug the volcano like a bathtub drain. The magma chamber is buried deep, often 5 to 15 kilometers underground, and it's fed by processes happening even deeper in the Earth's mantle. Plus, supervolcanoes don't erupt predictably. They can simmer for thousands of years, giving subtle hints like earthquakes or ground uplift. But pinning down the timing of an eruption is like trying to predict when your grumpy neighbor will finally snap. Then there's the risk of meddling. If you mess with a supervolcano the wrong way, you could theoretically trigger the very disaster you're trying to prevent. Imagine poking a sleeping dragon, except this dragon could bury continents in ash. So any plan to stop a supervolcano has to be precise, backed by rock-solid science, and, frankly, a little crazy. So how do you tame a geological monster? Scientists have floated some bold ideas, ranging from plausible to straight-up sci-fi. Let's break them down. 1. Cooling the magma chamber. One of the most talked about ideas comes from NASA's Jet Propulsion Laboratory (JPL). In 2017, researchers proposed a plan to cool Yellowstone's magma chamber to prevent an eruption. The logic is simple. Eruptions happen when the magma chamber gets too hot and pressurized, so if you can siphon off that heat, you might keep the beast dormant. The plan involves drilling deep wells up to 10 kilometers into the edges of the magma chamber and pumping in cold water. The water would absorb heat, turn to steam, and cycle back out, potentially generating geothermal energy as a bonus. Over time, this could lower the chamber's temperature enough to delay or prevent an eruption. NASA estimates this could extract 35 gigawatts of heat annually, enough to power millions of homes while cooling the volcano. Sounds great, right? But here's the catch. Drilling into a supervolcano is insanely risky. One wrong move and you could fracture the crust, releasing pressure in a way that triggers an eruption. 2. Depressurizing the system. Another idea is to relieve the pressure in the magma chamber before it reaches critical levels. This could involve drilling to release trapped gases, which are a major driver of explosive eruptions. Think of it like slowly letting air out of a balloon before it pops. Some researchers suggest controlled explosions or fracturing techniques to vent gases safely, but this approach is a gamble. Releasing pressure sounds nice, but if you miscalculate, you could destabilize the chamber and trigger an eruption. The 1991 eruption of Mount Pinatubo in the Philippines showed how gas release can lead to catastrophic explosions, and that was a regular volcano. Scaling that up to a supervolcano is like trying to perform brain surgery with a sledgehammer. Plus, we need to know exactly where and how to drill, which requires better imaging of magma chambers than we currently have. 3. Geoengineering the climate. If stopping the eruption itself is too hard, some scientists propose preparing for the aftermath. A supervolcano eruption could cool the planet by spewing ash and sulfur dioxide into the stratosphere, blocking sunlight. This happened after the 1815 Toba eruption, which caused the year without a summer and global famines. To counter this, geoengineering techniques like injecting reflective particles into the atmosphere to balance the cooling effect could theoretically stabilize temperatures. This isn't stopping the eruption, though it's damage control, and geoengineering is controversial. It's expensive, untested on this scale, and could have unintended side effects, like disrupting rainfall patterns or ocean ecosystems. Plus, it does nothing to address the ashfall that would bury crops, infrastructure, and communities. 4. Nuclear intervention. Now we're in sci-fi territory. Some have speculated about using nuclear explosions to disrupt a supervolcano's magma chamber, either to fracture it in a controlled way or to redirect magma flow. This idea pops up in online forums more than in serious scientific circles, but it's worth addressing because it's so dramatic. The problem? It's bonkers. A nuclear blast could fracture the crust unpredictably, potentially triggering an eruption instead of preventing one. The radiation fallout would be a disaster in itself, and the logistics of safely detonating a nuke underground near a supervolcano are a nightmare. Most scientists dismiss this as more Hollywood than reality. All these ideas sound exciting, but they're rooted in our current understanding of volcanology, and that understanding has gaps. We know supervolcanoes are driven by magma chambers, but we don't fully grasp how those chambers evolve over time. Advanced imaging, like seismic tomography, is helping us map these chambers in 3D, but we're still far from predicting eruptions with precision. For example, a 2023 study in Nature used machine learning to analyze seismic data from Yellowstone, revealing new details about its magma structure, but it still couldn't say when or if an eruption might happen. The cooling and depressurization ideas rely on geothermal and drilling tech, which is advancing but not ready for something as extreme as a supervolcano. NASA's plan, for instance, draws on existing geothermal projects, like those in Iceland, but scaling up to Yellowstone's size is a leap. Geoengineering, meanwhile, is still in its infancy, with small-scale experiments showing mixed results. The nuclear option, let us just say it is more likely to star in a blockbuster than a peer-reviewed journal. Beyond the science, there are practical hurdles. Funding is a big one. Billions of dollars for a project with no guaranteed success is a hard sell. Political will is another. Convincing governments to invest in a low-probability event is tough when there are more immediate crises. And then there's public perception. People already freak out about Yellowstone thanks to sensationalist documentaries. Proposing to drill into it or set off controlled explosions could spark panic, even if the science is sound. There's also the ethical question: should we mess with nature at this scale? Volcanoes are part of Earth's natural cycle, and trying to stop one could have consequences we can't predict. A cooled magma chamber might affect groundwater systems or trigger unforeseen seismic activity. Geoengineering could disrupt ecosystems in ways we don't yet understand. It's a classic case of human hubris versus nature's complexity. So can we stop a supervolcano eruption? Not yet, and maybe not ever. The most promising ideas, like cooling the magma chamber, are still theoretical and face massive technical and financial barriers. Depressurization is risky, geoengineering is a band-aid, and nuclear options are a non-starter. Our best bet right now is monitoring and preparation. The USGS and other agencies are getting better at detecting warning signs, and governments could invest more in disaster planning like stockpiling food or developing ash-resistant infrastructure. But let's not lose hope. Human ingenuity has tackled seemingly impossible challenges before, from landing on the moon to eradicating smallpox. If we can refine our tech and deepen our understanding of supervolcanoes, we might one day have a shot at taming these beasts. For now, though, they remain Earth's ultimate reminder that we're not always in control. What do you think? Should we keep pushing to stop supervolcanoes, or focus on surviving their wrath? Let's keep this conversation going.